And the last example is a technology question, so we're going to use our graphing calculator to graph this. Some things to notice. I mean, you could do a table of values as well. We have a decimal place. So I hope one thing that you notice in this is not going to be fun for your values. They're probably not going to be nice numbers in here. I'm going to go to my graphing calculator and type this in. So I go to y equals, maybe I'll clear out all of the other ones. And I have a negative 4.9x squared plus 50x plus 10. And when I go to graph it right now, this is what shows up. That doesn't look very parabola-like. Okay, but I know this parabola opens down, so does it make sense that it should like loop up over here and go to the right? So on your graphing calculator, normally when you start to graph, it goes from negative 10 to 10 and negative 10 to 10 on both your x and y axes. That's called the window of your graph. It's what you see through. If you want to see more, you'd have to make your window bigger. So we go to the window button, and you can play around. Right now, you can see, we're going to just play around with the x min and the x max and the y min and the y max. Right now, we're going from minus 10 to 10. I wanted to see more to my right. So I could change this to a bigger number. Maybe I pick 20, and I just see how that changes it. Now I have symmetry, right? Where's my vertex going to be? It's going to be up. So I need to change my y max in order to see that maximum. Because I know this one opens down. So I go back to my window, and maybe I change my y max to 20. And I graph. Not enough. So I go back to window, and maybe I change it to 30. And I graph. Not enough. I've been going up by tens. How high do you want me to go next? You can just keep going by tens, but that might take longer. I went up to 30. What should I try next? 100. Oh, that was good. That was way better than 50. Now that you got 100, does it feel like we're getting close though? What do you want to try next? Not 1,000, because we were pretty close. 150? Hey, there we go. So we've got the shape of our parabola. But the problem is I have no idea what my scale is here. And I'm going to show you how on your graphing calculator you can find key points. So I'm going to put them in red. I want to find my vertex. I want to find my x-intercepts. I want to find my y-intercept. Well, actually, your y-intercept is the one you can do without a calculator very easily. Your y-intercept is when x is 0. If you plug in 0 for t, does it become obvious that the answer will be 10? Because you'd have negative 4.9 times 0, then 50 times 0, plus 10. So that point is really easy. But your graphing calculator can find these other points as well. So we're going to go through how we find those things and what they represent in this question. So go back to my calculator. If I want to calculate anything on a graph, it's always above the trace button. It says calculate. So you push the second button, and then push the trace button to get to calculate. And these are all the things you can calculate on a graph. You can calculate a value. So we could have put 0 in for x and found out 10. We can find zeros. We're going to use that to find our x-intercepts. And we can find minimums and maximums. Can you see, to find our vertex, we'll do that first. To find our vertex, it's a maximum this time. So we push enter on maximum. Then what they ask you to do is look at your graph, see where the maximum is, go to the left side of it. So you see where my cursor is? If I go this way, you see that currently my cursor is to the left of my maximum. If I push enter, it does a little arrow, and some of them draw the line and some of them don't, depending on your calculator. Then it says go to the right side, so I'm going to move my cursor over to the right. Doesn't matter how far you go to the right, as long as you're to the right of it. If I push enter, it does another arrow. Do you see that our maximum is in between those two arrows? It says guess. When it says guess, everybody just pushes enter again. Nobody actually guesses. And it finds it exactly for you at 5.102, 137.551. Wow. Let's see if I can write that. 5.102, 137.551. I did 3 decimal places because in grade 12 they expect you to always write 3 decimal places. So I'm just practicing that. Okay, there's our vertex. Would not have been easy to find that through a table of values because of the decimal places. Next, on our calculator, we can also find number 2, the x-intercepts. And it's very similar to the maximum. It says find an x-intercept. You have to do them separately. So I'm going to get my cursor close to it. I'm going to find this one first. Again, it says go to the left side. So go somewhere to the left, push enter, it draws a line. Is my line to the left of the x-intercept? It is. Then go to the right side. So I'm going to move my cursor past, push enter, it draws a line to the right side. Is my x-intercept between those two lines? It is. I push enter again. And it happens at 10.4. 10.4, comma, this e to the minus 11 is like decimal 0.00000, like 10 zeros and then the 1, which is basically 0. So interpreting that as well. And we could find the other one, second, calculate, 0, number 2, but this time we have to move our cursor. And sometimes it's annoying to move it. So something you can also do is you can just type in a number. Like if I type in -2 and push enter, it draws it at -2, which can be a little bit faster. And for the right one, I can see that +2. I type in +2. Is that x-intercept between those two? It is. When it says guess, just push enter. And -0.196. That's our second value. Now, not all of you have graphing calculators. If you don't have a graphing calculator, the best online graphing calculator, which you can get an app for your phone or go onto Google, is called Desmos, D-E-S-M-O-S. So if you don't have a graphing calculator, or you also want to play around with it on Desmos, you just type in the equation. You're going to have to use the little hat button on your keyboard to get to the exponent. And the nice thing about Desmos is the following. For one, you can just like scroll in and out and move your mouse around so that it's a little bit easier to find the window. Also, really important things like the vertex, you just click on it. It's like, oh, you wanted to find the vertex? It knows that's an important point. Look at, it has all the decimal places there already. What's another important point you want to find? Oh, I want to find my x-intercept. There it is. Here's my other x-intercept. Here's my y-intercept. So finding those values can be very quick on Desmos, quicker than the graphing calculator. I just had to click on them, and they showed up. So this is another option for you. And actually, on the AP exams come with a graphing Desmos calculator available for you to use while you're on there. So you can use a graphing calculator or Desmos on AP exams, which is kind of cool. So it is worthwhile playing around with and graphing with it as well. Okay, so let's see if we've answered all the questions. A projectile is launched upwards. Its height, this is the graph of its height. Okay? what do we know about each of these things? The y-intercept tells you the initial height. It was initially launched at a height of 10. The vertex, that's when it reached its maximum height. 5.1 seconds after it was launched, it hit a maximum height of 137.5. The projectile stayed in the air for 10.4 seconds. And then it hit the ground. In this question, does it make sense that this is the only realistic part of the graph? You can't have it minus time. So when we're talking about domain in this question, the domain would be from 0 to 10.4. Normally domain of parabolas is everything, but this is a word problem. Its domain only makes sense in that section. Its range only makes sense from 0 to 137.531. Because it doesn't go into the ground and keep burrowing. It just hits the ground. And then after that, the graph doesn't make sense. So our vertex is the highest it ever gets. The one x-intercept tells us when it hits the ground. The other x-intercept doesn't make sense whatsoever, because that's negative time. Questions for practice on this one? Circle question number 10.